In this video, we'll have a look at the gradient of a line segment. And we'll also have a look at parallel lines, which we have seen before. Okay. So, the gradient of a line segment is the change in y divided by the change in x. In the case of a line segment, the change in y is the difference between the y coordinates, and the change in x is the difference between the x coordinates. So if I've got the point A and the point B with these coordinates, then, oh, that's a y2, then the gradient of the line AB is y2 minus y1 divided by x2 minus x1, or you can subtract them the other way around, it doesn't matter. But if you use the y1 minus y2, then you've got to do x1 minus x2. So subtract them the same way around. So if you use the second point first, then you've got to use the second point first in the denominator as well, and the same for the first point. So let's just have a look. And the other thing is that if you draw a diagram, you can always form a triangle, find rise over run, like we've been doing anyway, and go from there. So question 7, they want you to calculate the gradients of the line segments given in question 6. Okay, so P is 0, 1. This is what we had in our first example, and Q is 3, 10. So let me call these y1, x2, y2. So the gradient is, let me just write down the, so change in y minus change in x. So y2 is 10, y1 is 1, x2 is 3, x1 is 0, so this is 9 divided by 3, it's 3. You can also draw a diagram. Let's see, I've already done that. Draw a triangle between the 2 points. And then this side is 3, the other side, you count the squares, it's 9. And this is the rise, this is the change in y, and this is the run. And the gradient is rise divided by run, so it's 9 divided by 7. So this calculation, you can see it does the same thing, but you didn't have to draw a diagram. But I urge you to always draw a diagram, at least to check. Or if you forgot the formula, you just draw the diagram and find the gradient the way we've been always finding it. Okay, one more question. We will go through question 9. So we've got an unknown line which is parallel to the line y equals 2x minus 7. So parallel to this. And goes through the point two minus 5. Now, you can find the equation of a line if you know its gradient and a point that it passes through, or if you know 2 points that it passes through. So we've got 1 point, so all we need is the gradient. And when you see that 2 lines are parallel in coordinate geometry, they've got the same gradient. Okay, so parallel means same gradient. So the gradient of the given line is 2, because it's mx plus c. So m is 2. So the gradient of the unknown line is also 2. So the gradient is 2. So let's write down y equals mx plus c. And by the way, when we were doing this, calculating the gradient of a line segment, you might have noticed that this is exactly what we did last week when we were trying to find the gradient of a line that goes through 2 given points. This was exactly what we did. The 2 points that the line went through had these coordinates, and this is how we calculated that gradient. So to be honest, this is not very new. And well done if you remember that this is how we did that. Anyway, sorry about that. So now we know that m is 2. We don't know c, but that's why they gave us that point, this one. So we are substituting the coordinates of the point. So x is 2, y is minus 5. Let's do that. Minus 5 equals 2 times 2 plus c. So c is minus 9. So the equation of the line is y equals, so it's 2x plus negative 9, so it's 2x take away 9. Make sure you don't do plus minus 9. Okay, that's it. Now, again, it's coordinate geometry. You can always sketch and see if it's correct. I'm not going to do that now, but you can. So first you draw this straight line, then this point. Then from this point you go 1 to the right, 2 up, and so on, or just, try to draw a line that's parallel to that one and see if the equation looks like that. So see at least if the y-intercept is minus 9. Okay, now you can practice. So you can have a go at the rest of question 7. So these are to calculate the gradients of the line segments given in question 6. And then question 10. And I'll see you in the last video.